Okay guys, so this is our sixth session of the Data Logic Design Lab, and this session is going to probably be the probably bit longer than our last sessions, because in this session we will be looking for 2:1 multiplexer and 4:1 multiplexer. Both we will design with two different methods. Okay, so first let us see uh, what a multiplexer is comprises of. Okay, what does it comprises of? Okay, so I will just add one or two blank slides here. Okay, so what does a multiplexer do? Okay, so it will just take a number of inputs, okay, as per your need, and will just give a single output. Okay, it will give single output, but this decision is based on a number of select pins or select signals. Okay, okay, so not going into too much theory, if we that we have already covered in our theoretical sessions. If we look for a symbolic form or block diagram, so it will be something like this. Okay, this will be your inputs. Here you will have your select lines, and then here you will have output will always be one in a multiplexer. Okay, there will always be a single output in any kind of multiplexer, whether it is 2:1, 4:2, 8:1, or 16:1, whatever kind of multiplexer, there will always will be a single output. Okay, so inside this multiplexer box, what logic gates are present? Okay, so let us see that this multiplexer comprises of a single kind of logic gate, that is your AND gate. Okay, so this is your AND gate. Suppose you are making a 2:1 multiplexer. Okay, so you will have two AND gates. If you are making a 4:1 multiplexer, then you will have four AND gates. Okay, so first of all, let us see 2:1 multiplexer. So we will have two AND gates with two inputs, say I0 and I1. Okay, then another input of this AND gate will come from your select pin S, like this. Okay, there will be a NOT gate included prior inputting this value to your second AND gate. Okay, and then these output of these gates will be odd to get this single value. Okay, similarly you can make this 4:1 circuit also. Just connect this I0 here, then I1 to this gate, I2 to this gate, I3 to this gate. Now for connecting the select lines, as we have four inputs, okay, four, this can also be written as 2 to the power 2. So this 2 represents that we will have two select lines, S0 and S1. Okay, and corresponding to these two select lines, we will have four cases, that is S0 S1, S0 S1 का बार, S0 का बार S1, S0 का बार S1 का बार. Okay, so each of these cases must be wired to each one of these corresponding AND gates. So these AND gates will be three input AND gates. Okay, so now let us draw this in Logisim. Okay, so first let us make our 2:1. Okay, 2:1 multiplexer, let us make it. So what will we do? We will just take it AND gate, take the AND gate from here, make it a two terminal AND gate. Okay, then I will just copy it, copy, paste. Okay, I have to take two inputs and one select line. Okay, so I will just take two inputs. This will be my I0. Okay, then this will be my I1, and I do need a single select pin also. So let this be my select pin. Okay, and let me connect this now. Okay, now for connecting this select pin, I have to include a NOT gate for connecting to this second AND gate. So let me take a NOT gate also. I will place it here. Make the connection to select pin. Direct select pin goes direct to your first AND gate, and then this negative select pin will go to your second AND gate, and then the output of these AND gates will be odd. Okay, so convert this to two input OR gate and connect it. Okay, like this. These extra steps you can delete, and I will just take here like this. So what the theory says that if this pin goes high, okay, so what the theory says, if select equals to 1, then output should be the value of I1. Okay, else if the select pin is 0, then output should be I0. Okay, so let us check it. So currently as this is 0, okay, so whatever the value is given to the pin I0, it should be reflected at the output, and whatever the value of I1, it should not affect the output. Okay, so first let us change the value of I1. Okay, and for I0. Okay, so for this logic it is happening that the actually reverse of this thing is happening, that we have written here, if this is 1, then output will be I0. Okay, now check. As this is 0, the I1 is reflected to output, and as this goes high, the I0 is reflected to output. Okay, so this is working. Okay, now let us save this. Okay, so this is my 2:1 multiplexer. Okay, so this is done. Also let me write my name here. Okay. So this 2:1 multiplex is done. It was simple, and in the similar manner you can also design a 4:1 multiplexer. You just have to take 4 AND gates, connect the corresponding inputs and select pins, and get a output. But now let us see how to design a 4:1 multiplexer using 2:1 multiplexer as the component. Okay, so you may remember last I think in the third session of these labs, we have designed full adder using half adder. where we have used half adder as a sub circuit. So here also we are going to use this circuit of the 2:1 multiplexer as sub circuit for our full adder. So I will just make a new file. I will name it as 4:1 multiplexer. Okay, then I will include a 2:1 multiplexer sub circuit. In this 2:1 multiplexer sub circuit, I am just designing this. Let me delete this. There's no use here. And then I will edit its circuit representation. I will just stretch it a little bit so that connections are visible more clearly. This is our select pin. Let me drag it downward. Okay, these are our input pins. Okay, okay. So this is what our this is our 2:1 multiplexer. Okay, I will just place this in inside here. Okay, so control S, save it. Okay. Now I will come back to this main circuit. I will use this 2:1 multiplexer as a component. First 2:1 multiplexer, then second 2:1 multiplexer. Okay. So now what was our target? Our target was to select a single output from given four inputs because we are designing a 4:1 multiplexer. Okay. So let us connect these four inputs. This one, then we will have this one. Okay, then our third input, then our fourth input. Okay, so we have connected inputs to these two initial multiplexers. Now the thing is that these two multiplexers will individually give their single outputs, but again we have multiple outputs, okay, in our system. So again we need to employ one more 2:1 multiplexer to select a single output value from these temporary output values. Okay, so like this we can connect it, and at the end we will get a single value. Okay, so I will just connect here. Okay, now as for the select lines, as we know, we have four input cases, so we should have two select lines. Okay, so one select line we can give here. I will just take this pin, make it north facing, and connect it like this. Again I will take a pin, make it north facing, and connect it like this. Okay, arrange these on symmetry, and for this select pin we can just make this connection. Okay, because these both multiplexers should output these value at the same instant of time for this multiplexer, so that's why same uh, select pin should control these both of these multiplexers. Okay, so this circuit of ours is complete for the moment. Let us check it. So theoretically speaking, for the case 0 0, okay, one of these should be reflect. Okay, okay, so this pin is being reflected at the output, and other pins do not have any impact on the output. Okay, whether you switch them on individually or in a group. They do not have any impact on output when these are 0 0. Only this I0 will be effective at the output. Now as soon as I make it as this case as 0 1, so this pin also stops impacting the output, and now this pin will work at the output. Okay, so this is my 0 pin, this is my 1 pin. Okay, now as I go for 1 0, you can see this third pin is being reflected at the output, and this pin stops, and this pin and the second and this fourth pin, they do not have any impact on the output. Only this pin is being reflected at the output. Similarly, if I go for 1, then only this pin will be reflected at the output, the input applied at this pin. Okay, so this is the manual way of making a multiplexer. If again you need to use a multiplexer in some other big circuits, then you have also pre-made multiplexers already available in Logisim. Okay, here you can give your select pins like up to 5. Okay, so the inputs will automatically be automatically will be converted to a 32 input multiplexer. Okay, but output will always be a single bit output. Okay, so in this manner you can create a 2:1 multiplexer, or 4:1, or 8:1, whatever design you need. Let me export this file. Export jpg both of these images. Okay, so this is also done. Okay, so in next session we will see about the, now in next session will be somewhat different. Till now we have been designing some circuit and this adder or multiplexer or code converters, but in next session we will see about the proving of consensus theorem and De Morgan's law, or any other theorem from our curriculum. Okay, so that's all for this session. See you in next session.